Hey guys, I'm really excited to announce our next speaker, Clayton Coleman. So Clayton is the lead OpenShift architect at Red Hat. He was voted the top cloud native contributor by the Cloud Native Compute Foundation last year. And he's like basically a god in the Kubernetes community. So he is one of the driving forces, the thought leaders in that space. So we're really excited to have him. But before we bring him on stage, we wanted to spice things up and do a little giveaway. So I'm going to bring up John Osborne and Jamie Duncan, who are our lead OpenShift solutions architects for US public sector. And they've recently written a book, OpenShift in Action. And so we're going to do a little pop quiz to give away 2 copies. And the copies are signed by both the authors and Clayton.
Correct.
So John, do you want to do your quiz question first?
Trivia. I know I'm
Trivia
going to screw this one up. So, what is a social group of whales called?
Well, you only one person raised it.
Yeah. I'm giving it to the one guy who raised his hand out of the other 10 people that just blurted it out. So.
All right, so yeah, the gentleman in the glass, raise your hand again. Only one person raised their hand. It was you. Ross. Yeah, okay. All right, so that trivia was obviously too easy. We all thought it was going to be too hard.
John was worried it would be too hard, so he...
Yeah, Jesus, like 84 people. 84 people went to Zoology 101. Who knew? All right, so mine's going to be a little harder. In the Kubernetes logo, what science fiction show has a built-in joke? We have one person, 2 people raise their hands. Employees don't count, Sebastian. You've heard me say it before. All right, the teal, yeah.
Oh, here, we got a microphone.
I mean, it's science fiction. You got like you got a 1 in 5 shot.
Star Trek.
Good job. Yes.
Yay.
So and to explain it as we walk over to grab it, the Kubernetes logo has 7 sides. The thing that Google made before Kubernetes was called Borg, which is like a Star Trek bad guy. And the most popular Star Trek Borg was 7 of 9. Was her name? So it's a built-in Star Trek joke. All right, we have 2 copies given away.
Thanks, guys.
And now Clayton. Here, introduce Clayton. It's all.
I did. Oh.
And now we have Clayton Coleman with the very awkward segue.
So good morning, everyone. I'm Clayton Coleman. I'm going to talk today about Kubernetes and platforms. Before we get started, kind of wanted to get an idea for how I need to tailor this talk. Who here has heard about Kubernetes? Raise your hands. OK, dodge that bullet. How many people use Kubernetes or some variant of it today? OK, smaller group. And how many people use that in production? Same group? OK, small group. So I'll explain a little bit about Kubernetes as we go. This isn't a technical talk. This is more about where we want to be and what we're trying to solve. To help frame, when you think about Kubernetes, what it is that you think you can get out of it. So for those who are new to Kubernetes, it's a platform for running applications. And this is the right time for you to hear about it, because it's done. Right? Nothing more to see. Everything's boring. Just like Linux is done. And it's an important comparison, and I'll come back to it in a second. So why should you care about what I say? So this is my bragging sheet. I apologize for not being humble. But at the heart of it, I've been involved with Kubernetes since the very beginning. I was the first external committer to the Kubernetes repo outside of Google when they launched the project. I'm an API approver, an architect for Kubernetes. I'm a steering committee member. I generally try as much as possible to make Kubernetes the community successful, as well as Kubernetes the technical project successful. That's my job at Red Hat. I care very deeply about Kubernetes. I spend a lot of time arguing with people, trying to be a convincer and go-between. There's a ton of talented and motivated people from everywhere in the world who are involved in Kubernetes. And it's not quite like herding cats, because cats don't herd, period. But it's very similar to it. And I like to say that I'm responsible for most of the things that are wrong with Kubernetes and a few of the things that are right, just to remind ourselves that we have a long way to go, and there's a lot left to do, even though we're done. So I'm 100% biased. Everything you hear today is a very personal opinion of mine about what Kubernetes is and should be. There will be people who disagree with me, and that's fine. Open source communities are about people coming together, sharing ideas, disagreeing sometimes, and then still making something that's better than the sum of the parts. So the humility part of this is, I like to start with this quote because it's important to remember everything that has gone on before has some bearing on what we can do today, and I want to learn from the experiences of the past. So in our case, we're trying to build a successful open source application platform. Surprise, that's already been done. Linux is arguably the most successful community in history. The Linux kernel is probably the most successful open source project. Obviously, we can quibble over the details. There's plenty of other open source projects. I'm sure I've horribly offended someone in this room by saying that. We'll survive. Why is Linux successful? There's a lot of reasons. Motivation, money, best thing at the time, help people get their jobs done. I like to think that the reason that Linux is successful is because at the core of the Linux kernel is the idea that stable APIs are the most important thing for an ecosystem to evolve around. This is a quote from Linus, quite famous because he ruffled some feathers and said some very unnice things to people. But at the heart of it, it's about taking the position that as a platform, the most important thing you can do is provide stability for the people on top of you. Because there's many, many, many more of them than there are of kernel developers. And in this particular example, Linus was taking someone to task for the idea that I'll make this somebody else's problem. I will change an API, I'll break someone, they should fix their terrible code. It's not a great position because it's not just one person who might break, it's everyone. And so this mentality of keeping stable APIs, I'll come back to later. It's very important, I think, too, when we talk about what an application platform is and what it means to be a successful platform. The distributions were also a key enabler of the Linux success. So you have the kernel, which is this big, roughly monolithic thing everybody contributes into. It's got one source tree, thousands of branches, but it generally ships, and Linus's word is law. The distributions are different because the distributions are what take the thousands and thousands and thousands and thousands of other successful open source projects, give them a place to live. The maintainers, the people who build these distributions, take that software, make it consumable with varying degrees of intent. The distributions are different. So different Linux distributions encourage different needs. They're always moving forward, but they move at different rates. They prioritize different things, what kind of Linux desktop you're using, because this year is going to be the year of the Linux desktop, I guarantee it. They're a community. It allows people to make choices, and I think choices are important. Everybody has a different use case. I'll come back to that a little bit later. And finally, communities have failure modes. And really the only solution to a community falling apart is to have multiple communities. So there's a certain amount of resiliency in open source that is fundamental to having multiple competing and cooperating and individually evolving communities where everybody can find a place and move forward more or less together, kind of at a, like the herding cats analogy, moving forward to some goal in the future where software is better and we're all happier. So that's the context of Linux, a kernel and distributions, a community around those that a stable core that people build around. How does that apply to Kubernetes? Kubernetes is an application platform. It's not about infrastructure. Anybody who says that Kubernetes is about containers and is about Docker and is about cloud native, they're all lying to you. It's about applications. So in the beginning, the first concept in Kubernetes is the pod. There's lots of different ways that people can interpret what pods should be. All of them are equally valid. My preferred metaphor, the pod is the best abstraction to run Linux processes across multiple computers. That's it. That's its goal. It's to be able to take the things that work in Linux and run it on multiple machines and have 80, 90, 95% of it work. And there's, I'm not going to pretend like there aren't Windows containers and serverless computing and all this stuff. Like, those are important and useful, But Kubernetes was built around Linux containers for a very specific reason, because that's where most of the important server software that we depend on to build our applications to run our businesses runs. Best is objective. I don't think there's lots of people who would argue that Kubernetes is not the best at a particular abstraction. I think that our goal with Kubernetes and with the abstractions that we put in place is not to be too simple. Simple is easy, right? I'm going to be super opinionated and tell you I think I know the best way to work, and you're going to pick that and you're going to be happy, right? No, because the moment that decision of, well, I'm not happy with this, what do I do? You have no escape hatch. If you have no escape hatch, your solution isn't to stay on the platform and change a little bit. Your solution is to go find another platform. So platforms don't succeed by taking away choice, except they kind of do. Because if it's too complex, you can't build anything because everybody looks at it and they say, I don't really understand how this works. I'm not going to bother. So there's a Goldilocks zone, which is not too simple, not too complex. I think the sweet spot that we've tried to go for in Kubernetes is if people are complaining about too much YAML or it's got too many abstractions, but they still use it, that's roughly success. So it doesn't have too few knobs, but it doesn't have too many knobs. And it gives you just enough knobs that maybe your use case, you don't care about that knob, but enough people do that people keep joining the community. So we started with pods. Obviously, around pods, Linux processes run applications. What are the things that applications need to run across multiple computers? I say patterns here because patterns is a really important one. There's lots of different ways to say this. You're solving problems, adding features, building cloud-native software, blah, 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 blah. I think that the patterns that we're trying to go for are the patterns that make it simple to run applications. That's it. If a pattern doesn't make it simple to run an application or easy or possible, it's not worth it. And some of our abstractions are better than others. Some of the things that started in Kubernetes, there's lots of things that people would want to change about them now. New abstractions should be able to come in and take their place. But at a rough idea, they match the things that most developers would be familiar with. We talked about things like what would abstract storage look like so we don't expose EBS volumes or RAID arrays. We put an abstraction in front of it, made a best guess. It's based on some experience that Google and others had internally. We got it okay. It's not perfect. But at the end of the day, people were able to find value in it, build things around it. Vendors could bring their storage solutions. Worked for most people. And that's what Linux was about, was building just enough abstractions around hardware that developers could just do their darn jobs. And finally, Kubernetes in its early days was a bit of a monolith. And I don't mean that in the sense that it was all one process, but I do mean the sense that everything was compiled in. Part of that was due to the language that we picked for Kubernetes, which was Golang, which doesn't allow dynamic linking, or didn't at the time. We were also just trying to focus on making something that worked. So we talked about patterns, but what we didn't say was how you follow up on those patterns. So we shipped June of 2015, so I could do math, 3 years ago. It's been a crazy 3 years. It's been 3 years, right? 16, 17, terrible at math. It's been 3 years. It's been a crazy 3 years. The 1.0 Kubernetes was not perfect, but a lot of people found value in it. It made things easier. A lot of small companies picked it up. A lot of small individuals, just running 3 or 4 applications, and they found value in it. And then you had giant, massive deployments that existed, very soon after. Some of the I always get a little terrified of this, but some of the most critical things that you do in your day-to-day lives are running on an OpenShift 3.2, which is almost 2.5 years old now, which was certainly not something that we thought was going to be pushed to the limits and scale that it was. And each of these projects, Kubernetes has continued to evolve, OpenShift has evolved alongside it, but it is actually scary how quickly people found value in the idea of infrastructure that was built for applications. OpenShift 3, which is based around Kubernetes, launched at the same time. So wearing my OpenShift hat, we said we wanted to build Kubernetes, but we wanted to build enterprise-focused things. We wanted to do multi-tenancy because OpenShift already used to do multi-tenancy. We wanted to make it more friendly for developers. We wanted to give operators control of what happens on the platform and take some of that control away from developers. We wanted to at least get some ideas on paper about standardized patterns for making it easy to build images to run those containers. But because at this point in time everything was compiled in, so was OpenShift. We take a lot of cred for that. I always get a little annoyed by that. It's like I didn't see anybody sitting around helping, offering to put extension points in Kubernetes at 1.0, but we can move on from that. So the price of success for Kubernetes was useful. And so when you're successful and you're useful and you're an open source project, people want to contribute back. So when people come and contribute back, open source has its unique challenges. One of them is, hey, I have this great idea. Here, I've implemented it. Why don't you take it? And the challenge with that is, well, obviously, does it fit with these other features? Does it work? Does it have tests? What happens when you go away and I have to support this? And so as Kubernetes grew, we realized that we had a scaling problem. It wasn't something we thought about beforehand. We were like, oh, Google, we're so smart. Red Hat, we're so smart. We can do open source. This is really easy. Turns out community is really hard. And so humans scale poorly. Brian Grant, who's the Kubernetes architect at Google, called this the speed of light in Kubernetes, which was about this time the total number of commits that were going in on a daily basis to Kubernetes, the core GitHub repository, reached their peak. And for the last 3 years or so, it hasn't changed much. And this was basically the rate at which people could review and take ideas. So if there's a limit to how much you can contribute and do everything centralized, then what do you do? Well, the solution is not to try. Don't try to do that. The 80-20 rule, this is one of my favorite quotes, I think it was from the Microsoft team about Word, is that the 80-20 rule is that everybody only uses 20% of the features. The problem is it's a different 20% for every person. The end result for Kubernetes has that same pattern. If we're an application pattern platform, we can't implement every possible pattern ourselves. If we don't give you a knob and you need that knob, what do you do? So, and there'll always be edge cases and knobs that just don't apply to everybody. So if we don't give people a way out, people will go build their own platform. Kubernetes doesn't become more successful. And every time, just like with Linux, every time someone else joined Linux, everybody got a little bit better. Maybe it didn't seem like that at the time, but it created a foundation and a platform that other people could build on. We get more work done. We move more successfully forward. So the solution to not trying is make Kubernetes the kernel, the idea of a core of things that you need to run just enough of the applications that you can add in all the other stuff. And that's not our problem. That's your problem. Well, maybe not your problem, but it's the community's problem. Give people an outlet, an escape valve for them to build their solutions around the platform. And Linux did this quite successfully. The equivalent in Linux is the exec call, which allows you to start an ELF binary off of a file system, which is a really, really simple API. And that's what 99% of everything in the entire universe, basically, or everything on our planet at least, runs off of when it comes to software. So if we're a kernel and we need to have a user space, how do we encourage and enable that user space? So I'll skim over this part because it's actually pretty easy. We're done. That's what I meant by done, which is Kubernetes works mostly. The extension mechanisms are there mostly. People are successful building on top of it. So we kind of have two paths. It's taken 2 years to stabilize some of these extension patterns because we didn't want to rush it. And there's some architecture astronauts in there, and I won't name any names, but this guy, who didn't want to go too fast and make the wrong choices. We wanted to make sure that this would be a system that isn't just around for 5 years or 10 years, but is around for 20 or 30 years, to where the point where we all hate it and are waiting for the next new exciting thing to come along. There have been plenty of people who've successfully extended Kubernetes. I just put 4 logos up because I got tired of downloading logos off the internet. Istio on the far right is a service mesh. Service mesh is a simple idea, which is if you have all these services and they need to find out where everything else is and you want to talk to them and network can fail and you want to capture metrics, the old way was everybody compiled that into their applications. But then we stopped all using Java and we started adding other languages and that didn't work anymore. So then we said, okay, well, we'll put that outside the application And the application talks to a smart proxy that sits alongside it, and that proxy has all the magic logic for failover and load balancing and detection. And so Istio was the idea of you take that pattern in the implementation of it, you run it on top of Kubernetes, and you expose the pattern as an API that people can consume, and you make those stable APIs. That means that you could still run things on Kubernetes, but arguably, as we grow, Istio can be a very good foundation for, well, I just don't really want to deal with this whole security thing. Wouldn't it be really nice if there was something that layered on top of Kubernetes that gave me automatic end-to-end TLS protection, that automatically handed out credentials securely and rotated those credentials every 30 minutes so that instead of the developer managing secrets, the platform manages it and the operators manage the platform. Great idea. That's something that Kubernetes itself can benefit from, right? As we make Kubernetes extensible, we're going to be running all these things on top of Kubernetes that need to have security certificates and have those rotated and load balance and deal with failure. The idea of Istio, even though it's not perfect and it's still trying to get to 1.0, when it gets there, it will provide a set of capabilities that are optional, but make everybody's life a little bit easier. etcd CoreOS came up with the idea of an operator a few years ago. An operator is basically just a little bit of code that encodes domain knowledge about how to run software on top of flexible infrastructure. So instead of everybody in the world coming up with 100 different ways to run a database, you say, well, when we know how to run the database, why don't we just write that ourselves? And then we can install it and upgrade it, but then we can heal it, and then if it goes wrong, we can alert, and we can do backups, and we can provide rolling updates across HA, and we can allow it to scale. So the idea of operators is using the platform, exposing a really simple API that says, hey, I want this. I want to be able to run a database or a message queue. Putting all the operational complexity into code, which is not a new concept by any means. Infrastructure is code. But I think the realization that we are getting closer and closer to being able to use this application platform to do that is what is enabling these things to actually go from being great idea, probably not going to work, to wow, this could actually work. Argo is a workflow engine that runs on top of Kubernetes. It's just an open source project that lets you do complicated workflows of jobs and tasks. It's not perfect, but nobody on the Kubernetes project was involved in any way in making that successful. The community built it. The community, a set of people and companies have driven that to a very effective beta status. And so again, this is this idea of you can extend the platform, provide value. You want to be able to depend on that, but you don't necessarily need to write it yourself. Open Service Broker API, this was a big collaboration between IBM, Google, Pivotal, Red Hat, a number of others in the community to make it easy to consume external things into Kubernetes. This uses some of the extensions we put in and was very successful on its own. So we're done, right? Mission accomplished. We can all go home. That was easy. So this is the point where you say, OK, well, what's missing? What's next? How do we succeed like Linux? Because it's not enough to set the stage. It takes a ton of hard work to keep a community thriving, to make it valuable, to provide stability, to ensure that enterprises and companies and individuals can build and reliably continue to depend on that technology for years and years to come. I alluded to distributions earlier. Distributions in the Linux community play a really important role. Some of the things they do is they help distribute binaries and they make sure you know where it's coming from. They provide a release schedule. There's consistency. So, say someone hypothetically took all of these different open source components that run on top of Kubernetes and they said, hey, we're going to give you a set of versions that all work together. And not only are we going to help you update it, but if you update Kubernetes and that requires Istio to change or Argo to change or etcd to change, wouldn't it be nice if there was somebody on the hook who would say, oh yeah, we'll go do the testing for that and make sure that all works. And so the idea of distributions and not just Kubernetes itself, because that's not enough. I mean, it is. Like you can go quite a long way with just Kubernetes. But I think in the next few years, it'll become really obvious that it's not just about the kernel. It's about the ecosystem. So some of the things that distributions don't provide that I think is a gap that we can actually close, lifecycle of the host, monitoring and maintenance, or monitoring and management, and an easy upgrade story. And to be fair, many of these things have existed in Linux for a long time. They're not quite perfect. So for the next however many years, I would say our goal is to make the platform effortless. What's the difference between everything that's gone before in terms of application platforms? What's the next step that we need to manage the complexity of the applications that we have today and the applications we'll have 3, 5, and 10 years from now? So I alluded to stable APIs earlier, and I said if a pod, the core abstraction in Kubernetes is about a Linux process or a Windows process that can move across machines. If you can do both of those, if you can move an application from machine to machine, and you can rely on the stability of the underlying APIs, both at the kernel level as well as in the platform, you can upgrade and change everything in place. And so some big areas of focus for us personally at Red Hat and in the larger Kubernetes community will be around things like automated operations. And so this is something that you'll probably hear me and others in the Kubernetes community talk about for quite a long time to come. The idea that we've got a good platform, it can run things on top. But it's not enough to just install it once. It has its own life cycle. The things on top have their own life cycle. If we're going to be really, really successful at running tens of thousands of applications on top of this platform, probably be kind of important to make sure that platform doesn't break. I mean, that's just me, right? It needs security updates. If something goes wrong in one of the components, somebody needs to know. So a difference between what Kubernetes is trying to achieve and what Linux has achieved is about the idea that Kubernetes as an application platform that's intended to make all of the things that you need to run applications easier, more successful, extensible, so apply those same ideas to the platform itself and to the pieces that provide those tools. So I mentioned Istio. Somebody's going to have to upgrade Istio. If Istio upgrades and it breaks all the applications on the platform, that's not good, right? So ensuring that we have not just the idea that you can do all these things, but that you can keep doing them is going to be the biggest source of focus for us, because if we don't succeed at that, I'll probably keep using Kubernetes, but I'm not going to be happy. And I don't really want to spend the next 3 years apologizing to people because Kubernetes wasn't great. I want them to stop thinking about Kubernetes and start thinking about only the things they need to run their application. Because at the point we're at right now with the complexity that many people are dealing with in their data centers, in their businesses, we don't have time for that, right? Infrastructure has to become an invisible part of the world, not just the infrastructure that the cloud provider provides, right? Cloud providers they'll tell you, oh, no. These APIs we provide you, they're perfect. You don't have to worry about any of this. It'll just keep working forever. I've heard that line before. Well, I haven't personally. I'm not that old. The mainframe operators told us that. And they do. They work forever. The problem is that they keep working the same way, and business needs change. Software changes. How we interact with software changes. And so part of our goal with Kubernetes is not just to be cloud native, but to not have to care about the clouds. And if you do want to care, absolutely. The services the cloud providers provide will be incredibly valuable for everyone. But I think we can do better. A second part of this is it's not just the platform, but the extensions themselves. I alluded to operators. At a really high level, an operator is just about taking domain logic and putting it into code and making the person who knows that domain logic be responsible for it. And we've done this for a long time. They're called operations teams, right? It's nothing new. They have tools. I think the change that we're looking for is that operations teams are stressed. They have more applications. They have more responsibilities. They have security is more of a problem than ever. Ensuring that operations teams have the tools to automate the things that they don't need to care about so they can care about the things that they do is the job of software providers, the open source ecosystem, making the tools that your applications need automated, self-healing, self-monitoring, self-upgrading. That's something that is being done in a lot of different ways today. The goal here is that through Kubernetes, through a set of SDKs and a set of common patterns, that we actually have a chance now where we've been doing this for a while, is to start to collapse the open source ecosystem down on this runs best on Kubernetes. And not just does it run best, but it upgrades itself. It has stable APIs. Those sorts of guarantees are things that we can provide now that have been a challenge in the past. Recently, we launched I included the logo here because I was required to, the Operator SDK. It's a Kubernetes associated project in the ecosystem. It's just about trying to say, hey, we want to start ourselves down the path of making it easy to build these extensions to Kubernetes and to take some of the load off people's shoulders, whether that's vendors, software providers, organizations, IT shops, or individual contributors in the community. We want to help bring together open source communities to create stable software for everyone. And then finally, just at the end, everybody always asks about serverless. I have an opinion about serverless, which is serverless is really just a fancy way of saying, I don't want to think about these problems. And that's the same thing that we've been saying for years in every part of IT, is I don't want to think about these problems because they're not important to me. Some of the novel things about serverless is how well it's executed in Lambda, for instance. And the ability to tap into these almost infinite stores of data, which I'm sure many of the people in this room are familiar with, that's nothing new, right? That's not a problem that is new to anybody in big organizations or in government, as we've had this data for years. We're trying to do a better job of standardizing and making it available and using it to solve problems and to keep it under control. With serverless, there's lots of things we can go do. What I'd like to see is the idea that whether you have a big, complex application running on Kubernetes, something that's 15 years old, running C++ that's, for all intents and purposes, a giant monolith that nobody understands anymore, or whether you're writing just a simple function that takes data from a cloud provider store and moves it onto a message bus, no matter what, that works well on Kubernetes. And it's easy for a developer to not think about Kubernetes, to not think about the details of how it's run, and to make it easy for the operations teams to not have to think about a new way of making sure all those resources are being handed out. So it's trying to align all the problems that we have in both open source, in private data centers, as well as on the public cloud. If you have an application that wants to move across clouds, good luck moving your Lambda applications across clouds. And this will get better, right? There's lots of people in the ecosystem who have this problem. One particular approach that I think will be very important is to bring the open source communities together around the idea of making it easy to run any software, not just big complex software or simple software, but any software on a consistent application platform, to secure it the same way, to provision it the same way, to charge it and bill it the same way, no matter whether you're on a cloud provider or in your own data center. So serverless has an important role. It's going to be the shell script of the future. I'm pretty sure 5 or 6 years from now, you'll see Stack Overflow posts lamenting about all of the functions as a service scripts that people have created to go do insane things that nobody understands. We can get ahead of that because for all the flaws, Linux is about the kernel and it's about distributions, but it's really just about writing shell scripts until the darn thing works. And I think as a community, that is an outcome that I would be really happy to see, is it just works, and I can get on to doing the things that matter to me. So as a call to action here, if you aren't involved with Kubernetes, if you want to see things change, come find me. Please be involved. We want to make a platform like Linux that solves the problems of the people in this room and of the communities that we interact with on a day-to-day basis, and we'd love for you to be part of it. Thank you.